Alright, so here is my fourth practice quiz on AP Calc AB, and this can be used for both AB and BC since BC is 60% AB, so I'm just going to do mostly AB practice here, but this is the fourth quiz. I have 22 minutes to do the following 10 problems. I think this is AP pacing, but I don't know for sure. Let's just assume it's AP pacing. And I'll just go through each question one at a time, trying to explain it as much as I possibly can while still allotted with the given time. So start with number one. Okay, ignore the 0 out of 10. This is late, but all right, let's get started. Three, two, one, let's go. Okay, the limit of this. First, the limit as x approaches 2 of 3. Okay, anytime you see a limit on the AP exam, just always assume that it goes to 0 over 0. And actually, let's make this thinner. This thin. Uh, sure, 4. That seems pretty good. So just always assume that it goes to 0 over 0, because if they just make you plug in some random numbers and you get a random answer, that rarely happens because we're trying to use calculus here. This is a calc exam. So if you plug in 2 into here, actually the first thing what I realized is this could be factored. So it goes back to trig, algebra 2 trig or pre-calc, I guess. Maybe even algebra 1. But yeah, we have this right here over natural log x minus 1. So then you can just plug in 2 into here, plug in 2 into here, and you notice that this value goes to 0, and then this value, if you plug in 2 into here, natural log of 1, that is 0. So you have 0 over 0. What are we going to do here? What they're trying to do is L'Hopital's rule. So it's like if a limit of anything, right, if a is it goes to 0 over 0 or infinity over infinity, then what you can do is take the derivative of the top and the bottom. So it's the top and the bottom. And then you can try the limit again. So here, what I'm going to do is take the derivative of the top. So the derivative of the top is 6x minus 5. I'm just using, I forgot what that rule is again. Power rule? Yeah, just using power rule there. And the derivative of the bottom is just 1 over x minus 1, the derivative of natural log, right? So then now, and then technically it's chain rule, you multiply by 1 because this is the inside function, but yeah, I mean, yeah, that's very trivial. So then now we plug in 2 into there, 2 into there. So then now we have, you just do this arithmetic 7 over 1. So this is 7. So answer is A. Let's move on. Let G be the piecewise function, blah, blah, blah. What is, okay, I'm skipping. There's a reason why I'm skipping, because this is one of the very few things that I'm not completely sure of, and I have to review later. And that's totally fine on the AP exam. You only need a 65% to get a 5. So you don't need to stress about that. Okay, we have the derivative of 3, x squared to 3 of half sine t dt. Okay, so whenever you see a derivative and an integral right next to each other, that is the second fundamental theorem of calculus, which basically says if you have the derivative of something, um, let's just say any number, so a is a constant to x of f of x dx, that's going to be, or actually, or let's say, let's make this better. Let's just make it a function of t. So f of t dt, then that's going to be f of x times the derivative of, or actually let's just say, okay, a is a constant, right? And then let's just say we have u, right? Or let's say u. So then it'll be f of u times du dt. So you just plug in the top value, whatever, into here, and then you just do chain rule. So here, what we have to do is we need a variable on top. And I don't think so I have time to fully explain why. But yeah, you can honestly just take this integral and put the derivative if you really have the time to do it. But here's what I'm going to do. So, okay, in integral, when you go from one way to another, right, that's just one area, right? And if you go the other way, so let's say we go from, instead of x squared to 3, we go from 3 to x squared, right? You're just reversing it, so that's basically making it negative area. So if you reverse these limits of integration, then you also have to make this negative as well. So it's negative, and then you can just proceed with this dt. You can bring the half out, so I'm just going to say negative half dx ddx 3 to yeah, just going to do that. So then now we can just plug this in, this second fundamental theorem of calculus. So you have f times sine of x squared, and then you need to take the derivative of x squared, which is 2x, and then you see the 2's cancel each other out here. So what we're left with is a, negative x sine x squared. All right. 4. The graph of g prime of x, the derivative of g, shown above is composed of a semicircle and a line segment. Determine g of 7 given that g of 0 equal to 2 pi. Okay, so we're given, okay, so they're giving us g prime, and I think a good thing to note is the integral of g prime, or aka the area of g prime, is going to be g, right? So yeah, because anytime you get the area, the derivative and the integral, they outdo each other basically. So yeah, if you go from g to g prime, right? That's you take the derivative, right? In order to inverse from g prime to g, you have to take the integral. So basically finding the area under g. Okay, how much time do we have? Oh, we have a lot of time. So yeah, we take the area under g, and that, sorry, the area under g prime, and that would be our change in, I guess you can say, position. So if you have g of 0 as our starting, or okay, I'm getting ahead of myself. This is the first fundamental theorem of calculus, actually. So it's basically saying, let's say you have a to b of g prime of x dx. That's basically saying when you take the integral, so that's going to get from the g prime, right? When you take the integral, that's going to be g, but then it's going to be g of x from a to b. So that's going to be g of b minus g of a, right? So if you understand how the integral works, then you put the limits of integration there. So similarly, so 0 to 7 of g prime of x, that's going to be equal to g of x, right? The integral of g prime is g, and you go from 0 to 7. Then now it's going to be g of 7 minus g of 0, right? So, okay. Oh, I forgot the dx right there. Okay, so 0 to 7 of g prime x dx, that is going to be just the area under the curve, right? So the area from 0 to 7. So let's say from, if you look very closely, I'm just going to zoom in here, right here on this graph. So from 0 to 4, this is part of a circle. The circle has a radius of 4, which means the whole circle will have, what is it? The whole circle will have an area of 16 pi, or pi r squared, right? Where the radius is 4, so 4 squared pi. But then it's just a quarter circle, so you just take a quarter of it. So that would just be 4 pi. And from 4 to 7, the remaining stuff, that's just a triangle. That's with half, so it's half times based on height. So base is 3, and the height is, we have to use positive and negative, so it'll be negative 4, because there's quote unquote negative area. So then that is 4 pi, then this goes, this evaluates to minus 6, I believe. No. Yes. This is the, right there. And that's supposed to equal, according to our equation, g of 7 minus g of 0, right? Let's zoom back in. There we go. They've given us that g of 0 is 2 pi. So then now, if we just add, yeah, so we have, I'm just going to say 4 pi minus 6 is equal to g of 7 minus 2 pi. Then now in order to figure out g of 7, you just add 2 pi to both sides. And we get g of 7 equals 6 pi minus 6. That's going to be D. All right. How are we doing on time? 9 minutes. Okay, I gotta speed up just a tad bit. Um, okay, so I think this is fairly self-explanatory. So you can separate integrals basically. Okay, I'm getting too zoomed out. Let's fix that. So we have 3 to 5 of g of x dx equals 6, right? So if you multiply, okay, actually this, because I'm running out of time, I'm just going to do this. Uh, I'm just going to first separate. So we have 2, 3 to 5 of gx dx minus 3 to 5 of h of x dx, right? So you can separate it out like that. Hopefully you can like see it. So I separated this integral from this integral, and then this constant, I could take it out. So then now this is 2 times, they're given this as 6, and then minus h of x is given us as 4. So that's 12 minus 4, which is 8. 8. I hate this. I don't like finding minimum value, so I'm just going to skip and move on. 7. Okay, let h be a twice differentiable function. Okay, how are we doing on time? Okay. Twice differentiable function, we have h of negative 5 equals 40, and then h of 15 to negative 20. So it's twice differentiable, decreasing function. Okay, so it is differentiable in this interval. 40. So let's just say this is 5, negative 5, 40, and then this is like 15, negative 20. That's how I'm seeing it here. Okay, which must be twice differentiable, decreasing function. Okay, what's the slope of this? This is 60 over negative 20, right? So negative 3. H of t has a tangent line of some t on the interval. Okay, I think I can be confident on that. Okay, yeah, has a tangent line, twice differentiable function. Okay, yeah, that's mean value theorem. Mean value theorem. So it's basically if there's the secant line or the what's it tangent, not tangent, the slope between 2 points is one value, then there's going to be some point on the curve where the slope itself is going to be the same value. That's mean value theorem, and I don't have time to search that, so search that up on your own. All right, number 8. The average value of a function is 4. What is the area of the region bounded by f of x? The line x equals 3, the x-axis and the y. Oh, okay. So it's basically saying, okay, we have this function from 0 to 3, the average value is 4. And okay, this is how I like to think about it. What's the average value of this function? It's 4. Like the height of it is 4. So it's all the 4, it's all the way across, right? And this is 3. So no matter if the average value is 4, then this total area under from 0 to 3, so this is the x-axis, y-axis, x and 3, it has to be 12. So honestly, yeah, it can be very confusing because you could have some random thing all over the place, but like you can only get this average value if this is 12, and then all you have to do is you got to get the x interval, right? And you have to divide it, so it's multiplied by 1/3. So that's how you determine by average. It's a sum of all this area divided by the amount of intervals that you're doing, which is 3. So that will give you an average value of 4. So the area must be 12 under the curve. It's very trippy, but very not trippy at the same time. Okay, another second fundamental theorem of calculus. And how to do this is basically you just plug in whatever the sign of x, the variable stuff into here. So it's e sine of x plus 5. And then you got to take the derivative of this part that you plugged in. So that would just be cosine. So that is A right there. It's not terribly difficult. Okay, we're doing really good on time actually. But let's go to 10. When studying the number of questions we're just getting correct, increase at a rate modeled by QT and Q, where T is in time in hours and Q of T is measured in questions correct per hour. Which expression will give the number of questions Verge got in 3 hours of studying? Okay, so if you know that Q of T is the rate, it's a rate. So it's correct per hour. So if you're to draw a graph, right? So it's like correct per hour will be on the y-axis, correct per hour. And then hour would be on the x-axis. And then you'll be like, okay, at this hour, his rate would be this many questions correct per hour. But now what happens when you multiply the y-axis and the x-axis together? What happens if you get this area, right? When you multiply the x and y? Well, correct per hour times hour, right? The hours just cancel each other out, and then you're left with the questions correct. So in order to figure out the questions correct, you need to find the integral of this rate. Well, the rate is q of t. So then you need to take the integral of q of t in order to figure out the area, in order to figure out how much questions it got correct. So here, q of t minus q of 0, that's just the change in rate. That's not the number of questions correct. Q prime, that's correct per hour per hour. That's not the same thing as just the number of questions correct. So A is also q prime. Q prime, the integral of q prime is just q, right? And q is just a rate. The only answer that's viable is B, right? You're taking the integral of the rate in order to get the actual amount. Think about a velocity, right? The integral of velocity. Velocity is a rate of position, but you take the integral of velocity, it's just position. This is a very similar situation right over here. Yeah, you have a rate of correct per hour, you take the integral of that, and you're going to get the number correct. So let's go back to 6. I think 6 is doable. I'll do 6 first before doing 2. Just purely because 6. All right. What is the minimum value of G? Okay, so minimums. Minimums mean you have something right here, and what is it? The slope of a minimum is 0. That's the calculus function behind minimums and maximums. Then we're going to find G prime. G prime using power rules, 5x to the fourth minus 15x squared minus 20. Now, what is the minimum value? Try to find when this, oh boy, this is a fun one. This is going to factor out the 5, so we have x squared minus, okay, how much time we have? Okay, I need to really speed up here. 3x squared, okay, so now we're left with x, I'm just factoring it here, so 1 and 4 plus 1, x minus 4. Okay, so here, if you know math, this is going to be plus or minus I, right? There are no real solutions here, so that's going to go out of the window. Here, you have plus or minus 2. In order for this to equal 0, right, you can choose each of these, so it's going to be plus or minus 2. And either of these factors will cause this entire thing to be 0, because one of these factors would be 0, right? So then now we have to check each one. Negative 2, 2, right? So not only is thing 0, but the slope is going from negative to positive. Or honestly, what we could do is we can save a bunch of time and just plug in negative 2 into here. Because I think that's going to be the negative value. It's going to be the smallest value here because you can take advantage of multiple choice. It's going to be negative 5 plus 8 times 8. Or actually, okay, actually that's probably not the smartest idea. 0. Okay, where's the slope? Okay, so here the slope when x is 0 is going to be negative. and it's going to be positive here, it's going to be positive here. Yeah, if you just plug in numbers, this is G prime, by the way. So G prime is going to be positive, negative, positive. If you plug in numbers less than -2, you're going to get a positive slope here. You're going to get a negative slope here. So then positive to negative. So, okay, -2 is not the minimum. It's 2 that's the minimum. So it's going to be this to -40, -40. Yeah, there we go. So then that would be -48. That would be A right there. Sorry, I'm rushing this one really bad. But you can slow it down on your own on a later time. Okay. Think this one, I honestly, let's see. I don't know what is is it non-existent? Okay, if it was, I could say it's non-existent, but let's just do the math. So integral, so then integral of each of those, right? It'll be x squared. Well, I can zoom in a lot more. X squared, 6x, and x cubed to the third. I'm really intrigued to say just, does it have to be differentiable everywhere? I honestly don't even know. Um, -1 to 3, -1 to 3, -1 to 3. So that's going to be 9 minus 1, so it's going to be 8 for the top. It's going to be 18. Oh, so that's just going to be 24. And then that's here it's going to be 9 minus -1/3, which is 28 thirds. I really wanted to say it's non-existent. Um, hmm, X, where, hmm. Yeah, I don't. Oh, oh no no no. So it's just 8 plus. Okay, I'm just gonna say non-existent. Let's just see what happened. Uh, okay, I think I might be wrong actually because I remember you can take areas under that. So oh, 8 out of 10. Okay. Okay, so here apparently you could take the area under that. So that would be just x squared from -1 to 3. So that's just going to be 9 minus 1, which is 8. And then from here, x squared, that's going to be x cubed over 3 from -1 to 3. That would be, what is this? 3 cubes, that would be 9 minus -1/3. So that would be, oh, oh, no, 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 I'm screwing this up. Um, I just realized what I'm doing wrong. Because okay, yeah, yeah, I see what I'm doing here. Okay. So this is honestly a graph, right? And I know we can take areas under graphs. It doesn't necessarily have to be differentiable. So here we can do, this is for less than 1. So basically now the integral will have to go from -1 to 1 of 2x dx. Yeah. So then that would just be x squared from 1 to -1. So that's going to be, okay, let me zoom in, kind of unseeable. So then this would just be 1 minus 1, -1 squared. Yeah, this would be 0. Okay, that's cool. So then now, uh, 1 doesn't matter. It's a 6 It doesn't matter if that's the case. So now here we go from 1 to 3, because for x greater than 1, we have x squared, so then you take that, which is x cubed over 3, 1 to 3. And that is, okay, so then that is 27 thirds minus 1 third, which is 26 thirds. So that's how that's the case. Um, 2. Oh, okay. I fell for a trap. Okay. Not happy with this, but they said 3 to 5 g of x dx is equal to 6, but 5 to 3 of h of x dx equal to 4. Yeah, and like this question was super easy. I don't know how I fell for this. Okay, at least I know what I did wrong, and I know what to look out for in the AP exam. So when you switch around these limits of integration, so you go from, let's say, 3 to 5, right? And let's say you're getting this area under the curve, right? You're having some sort of area in one direction, but when you, let's say you go from 5 to 3, when you're going in the opposite direction, you're flipping the area around. So that means if we flip this around, right? If we go from 3 to 5 of h of x dx, instead of 4, you're going to flip that around, and that's going to be negative 4. So then now we go back to our question. Let's see if we can find it. Should be very close. Yeah, so here, instead of 4, it would be negative 4. So instead of 8, it would be 12 plus, sorry, 12 minus negative 4, which is 12 plus 4, which is 16. So 8 is it's a trap answer. The AP Calc test graders know that is a very good trap answer. So make sure you're reading it very carefully and basically do not be like me. But all the other questions we got right, so that is good. Yeah, so key takeaways of this video is to know your first and second fundamental theorem of calculus, and make sure to read questions very carefully, otherwise you're going to make stupid mistakes like these on the exam. Alright, that is pretty much it from me today. Hopefully you'll stick around for my 5th practice quiz. Until next time, I'll see you next time. Thank you.